Hi, I'm Joe Bailey, Executive Director with the Quest program here at the University of Maryland. I wanted to spend a few minutes telling you about a very useful quality tool called tornado diagrams, and this is going to allow us to go ahead and take a look at the sensitivity of some of the models that we create. So the first thing that we need to do is we need to know what our dependent variable is going to be. Let's say a dependent variable might be cost, and we might be trying to minimize cost. There could be lots of different things that we can have as input to the cost model. So we could have people, material, we could have, let's say, processes. And each one of these will be an estimate of what the overall cost is going to be. We could take the total of this, and let's say that's going to be x. And each one of these then would be a factor into this x1, x2, and x3. And the sum of that would be, and I'll make this a capital X. Well, because these are estimates, it's possible that our factors that are input to the cost function could actually take upper bounds and lower bounds. So I'll call this x1 under bar and x1 over bar, x2 under, x2 over, x3 under, x3 over. And of course, as we vary these different things, we can imagine that the total cost is going to change as well. So in other words, if the people cost is actually at a lower bound, then the overall cost, capital X, will actually be less. What we can do is we can take a look at how all the variation in our inputs leads to variation in our output. So let's say if I just put some numbers associated with this, if I have 50, 100, and 150, and then I can take a look at material costs, which could be 20, 40, or 60, and then for processes it could be 10, 15, and 20. Each one of these costs, right, is going to be a factor of the cost, but not the overall cost, because we could have multiples of people, material, and processes. So therefore, while x, the mean value, could actually go as low as, let's say, 1,000, but as high as 2,000, with, in this case, maybe a mean of 1,500. And that mean is going to go ahead and vary based upon all these inputs. So what we're going to do in a tornado diagram is we're going to look at how the output, the dependent variable, is going to change as we see variation of the independent variables. And we're going to go ahead and start with our mean value of the $1,500, and then we're going to take a look at what causes the most variation in that dependent variable. So in this particular model, it could be that the process drives most of this, and the process can actually drive the value between, let's say, 1,200 and 1,700. The next thing that might actually cause a variation, we could call this process, is we could have material. The material can cause us to go between, let's say, 1,300 and 1,000, let's say, 650. You'll notice that these tornadoes don't actually have to be symmetrical. They can actually be skewed one direction or another. And then after process, we could have, let's say, people. So what we're seeing here is, again, the focus is on the dependent variable, and we're seeing how there's variation in the dependent variable based upon variation of all the independent variables. In our graph of our tornado, because things are ranked ordered from the one that causes the most variable to less variability, is basically a nice visual tool to look at sensitivity analysis of our model. There's a lot of applications of this that you'll find useful. This will help us identify how we can maybe gain more confidence in some of the variability in our inputs, but it could also make us understand how our output actually might vary based upon some estimate value, but also the confidence associated with that value. So for tornado diagrams, this has been Joe Bailey of the Quest program. Thank you.